Hello everyone, welcome to CoddingAdda. Today we will discuss on our project and I am very excited to share our real life project with you. In this project, we will discuss on many topics like Go modules and obviously before that how to set up VS Code, installation of Go, then creating Go modules, publishing Go modules and using your own Go modules and also third-party Go modules in your project. Microservice architecture, implementation in Go, all those things we'll discuss in this project. So it will be a very exciting lecture. So without further delay, let's get started. First, we will focus on setting up Golang in your local system. Till now, in all the lecture, we used Go Playground for working with Go's features. Now we will set up Go in our local system and we'll work on a real life project. So what you have to do? You have to open this Go developer site that is go.dev. Then go to download section. In this section, you have to install Go runtime based on your OS. As I am using Mac and the version is more than 11, I have to use just one. So you can select the appropriate Go runtime based on your OS. Just you have to download from here and you have to install. That's all. I have already downloaded and installed Go in my local system. How you will verify whether Go is installed properly or not after downloading and installation? Just you have to go to terminal and you have to write one command Go version. Then you'll find the Go version that is installed in your system. So I am using 1.18.3. This is the latest version at the time of recording of this video and we will continue with this version. We have written one file that is main.go. This is simple Go file to test further whether our setup is correct or not. We will run go run main.go and we are getting the output. And so now we are ready to work with a real-time project. So without further delay, we'll jump into our agenda. So what we are going to demonstrate here, let's quickly discuss that. We will create different Go modules for our order management system. Let's say our project is order management system. I think you have already some picture in your mind of popular e-commerce site. Yes, You can imagine e-commerce site like Amazon. So let's say we have to build backend services for our e-commerce application. So typically in a e-commerce application, we have modules like product, we have cart module, we have checkout module, we have order module, there will be shipping module. So there will be lots of other modules. Okay. And we will be some core modules also, which will share core functions across other modules. So this OMS core will be the library. This is not a service. This will be a library. And it will expose some function that we'll use in other services. This product, cart, checkout, order, this all will be small services. So those are MS, microservice. And this is library. So all these are obviously Go module. But the difference is this is OMS code will be library and this will be services. So this will run in a port as a service. So we'll expose those services in a port. So we'll see all those things step by step. So this module feature is exposed in Go above 1.11 version, or you can say from 1.11 version. So before 1.11, there is no support of module in Go. So then we have to use some third-party vendor to manage Go modules to do the dependency management. So from 1.11, Go supports dependency management in build. And we are using here 1.18 version to build this project. So this go.module file is the dependency management file. You can think of this is similar as package.json in Node npm and in Maven pom.xml in Gradle build.gradle. Similar file is go.mom. So this will list all the dependencies that you are using in your project, and it will help us to install all the dependencies when you are checking out a new project from the repository. And we are using here Postgres database. Let me go to in my VS Code. So we already know from 1.11 Go is supporting module concepts in build. So what we will do, we'll do how to create a module, how to publish a module, then obviously before publishing how to tag in the module and how to use one module in another module. All those things we will discuss. So this is OMS core project. If you go to my GitHub, I will share all the links in the description. OMS core. This is the OMS core repository. So one module is a repository in GitHub. Go prefers single module per repository. There can be nested directories, packages. Obviously, you have, but Go encourages single module per repository. That means you will have only one go.mod file in a repository. So this is the file go.mod file. This is your module name, github.com. This is the site where you are storing your projects. This is the origin, github.com. Then it's your username. Then this is the repository name, OMS code. This is the Go version you are using. We are using 1.18 required. All these three modules are required in this project. And this is the require, this lists down all the indirect dependency here. So here we'll only focus on those things. So we are using UUID package. We are using OMS code package, and we are using Viper package. Viper is for environment management library. Okay, so before that, what I have done, I have checked out this OMS code from my GitHub. And if you want to start fresh, then you have to create one directory. Okay, so I will go to my, okay, this is my project folder. So I have created, when I have started oms.core directory, this project. Okay, let me go to OMS. So when you start fresh, you have to create mkdir oms-code one project. Okay, then what you have to do, you have to initialize module here. Okay, so our step will be create a new empty directory, that is OMS code. Now you have to run this command, go mod init github.com, then your user ID of GitHub, and this is your folder OMS code. So this will be your package name. This will be your module. Okay. Now what you will do, you will write your codes, all those things here. Now you have to run this command, go mod td. This will help you to list down all of your dependencies. So now we have already created one directory for our project, that is OMS code, and we entered in that directory already. So for the first time, you don't have any files here, right? Just you have created one blank directory. So what you have to do now, you have to initialize your module by running this command. If I run this command, this will tell that you have already go.mod file. In your case, it will create this go.mod file. Now you will be able to write your project's code here. And to create, or rather to add all the dependencies, first time you will have code in this file till line number 3. And what you have to do, you have to run this command, go mod td to add the dependencies you are using in your project or to clean up the dependencies that you are not using now in your project. Maybe you are using before. So what you have to do, you have to run this command. Go mod td. Okay. So then it will create all the dependencies here with the versions. Okay. So now you have already set up your directory. So you have now go.mod file. You have you can create git ignore file. Okay, this is the sample git ignore file for Go best project. You can take it from the repository, from my repository. I will share all this code. And you have the readme file. All those things are there. Now we'll focus on the codes we have written here. So we have already created our module. Now you have understood how to create modules. You have to create your empty directory. Then you have to enter that directory. You have to run go mod init. This command, this is your github.com site name, this is your username, and this is your module name. We have used the same name as our directory. Now we have written all the code and added all the dependencies. Then we need to run this command go mod td, or you can run go build command also. That will also add all the dependencies, but that will not clean up the dependencies. Okay, so go mod td will be the best option to add and clean all the dependencies that is no longer used in the project. Okay, so now you have in the position to write your business logics in this module. So let's say we have written all the codes in the module. Okay, now how we'll publish this module? First, you have to commit all the codes. Let me modify something here. This module will be our other code one. Okay, next we will commit this. We have written all the code. So we have, if we do git status, it Chuma P. So if we do git status, then we can see have modified all this file. I will add all the files, add step all, then we'll commit our file, dated for not file, not and readme file. Okay, now we can push our this is post and our repository in our remote repository. Okay, now what we will do? We have to tag our. Let me check the latest tag in our project. GitHub tag. We have already one tag and one release. Okay, V001. Now what will be our tag? V002. So we are using semantic release version. This is your major. This is your minor. This is your patch. Okay, so when you will use major version, when you have any breaking change, then you have to update this. When you have some feature, you have added some feature, this will be your minor version update plus one. This is your patch when you are fixing bath in your existing function. So I am tagging. Now I will push get push v0 02 producing v002. Now I have pushed new tag. If I go here, if I refresh here, then we'll find yes, this is already updated. Now we can give release with this tag. So what we have to do, so after writing our code, we have to publish our code. So we have to commit, push our code, then we have to tag our code with the semantic version, then we'll push our tag in our remote repository. Now you will be able to see all the tags and give release with that tag from the GitHub. Okay, now we'll explain how to use this module in another module in our microservice. Now, what we want to do, we want to use this OMS core module in our other modules. Let's say we want to use OMS core module in our product module. I will share all the links of GitHub code base in the description. So what is our module name here in OMS core? This is github.com. So people OMS core. We want to use this module in our OMS product. So what we have done in our go.module, we have used that. github.com Sophicul OMS. Okay, and we are using version 0.0.1, the previous version. And how we are importing this? We have to import this in the file where we want to. In API Go, we want to use. So we have imported this, and after this last slash, we can give the package name that we have in our OMS core. So in our OMS core, we have model and utils. Yes, this is our models package, and this is our utils package. In utils package, we have this config.go and this helper. So from models package, we want to use some model. Like we want to use product model in our OMS product project. So this model, if I search with this, then we'll find okay. Models.product. We are using product. It has ID, name, description, available quantity, reserved quantity. Same thing, the same code it's showing here. Okay, this all the properties. So to use another module, we have to import that module with the tag number that we want to use. Then after in go.mod file mentioning the dependency, we have to input this in the file where we want to use that module. We have to do in only two things. The same way we did in our another languages, like in Node.js, we have to add in our package.json as a dependency, right? Then we have to import that package in the file where we want to use that module. Similar way in Java, we have to define the dependency in our pom.xml or build.gradle file, And the file where we want to use, we have to import the required file. Let's say now we want to use another module in this product module. So we have another module. If I go to here, we have another module, OMS REST plan. So this module is a common module for API calls, for REST API call. That's we have created one module, one common library, and we'll use this library across all of our projects to do the API calls. Now we want to use this module in our OMS product. We have version till 002 in our OMS REST plan. What we have to do to use this OMS core, let's say we want to use here our OMS core. So what we can do, go get, and this is our module. So we'll do go get github.com OMS REST plan. Okay, so let me go to our project folder, OMS product. It's telling added github.com Sophicul OMS REST client version v002. That's OMS REST client. So now we have to import this. Let's name it as REST util. This is the alias name of this. Now what we will do, we'll use some functionality from there. Let me copy some code here. We want to use this functionality here. Maybe here. Now what we are doing, REST util. Okay, this is REST util. Now we are using REST util dot get. Then we are passing some variables. So we have one function here. If we go to REST util dot client, then we will find we have some function get, and that we are calling here, and we are passing the URL, get URL, and it will return us the response and error. We are calling, we are taking response and not taking error, then we are printing. Okay, so we have to import FMT also. That is not imported. Then what we will do? We have to use the package name here because this is under REST util and you want to use that. Okay. Now it has all the things. Now what we have to do? We have to run go mod td. Go mod td. What it's telling? It's complaining us could not import github.com so people OMS REST client REST util. No required module provides package OMS REST client. Okay. REST util. Let me go to there. Okay, so the package name is REST-util. REST-util. We have to use REST-util. Okay, now it's done. Let me run once again. Go more td. Now it's already added in our dependency. Okay, so we have successfully used our OMS REST client. Congratulations. So now you have the better idea how to use another package. Maybe it's your own package or any other third-party package. What we have to do, we have to import that package in the file where you want to use. You can use any subdirectory after your module name. Then this is the alias name you can use or you cannot use. If you don't use, then default it will be rest-util. You have to call rest-util dot something here, like models dot utils dot something. And if you give one alias name, then you can call it by this alias name. Okay, this is now rest util referring to the package here, rest util in OMS REST plan. So you can call any function defined here. Okay, now you are printing the response. Great. We have created our own module and now we have used our own module in another module, another microservices, that is OMS product. Let me run this go run dot. If you use go run dot, then it will automatically run the main file. Application is running 3004 and it's connecting to the Postgre database. So as it is a microservice, we have exposed in at port 3004. And also we have used Postgre to store our data. Typically we'll use in our real life project always some database. Most of the cases to store our data. Maybe sometimes file because we have to persist the data anyway. It cannot be volatile. Okay, so now I'll explain you this microservice and also OMS core library. So you have now understanding of how to write one library and how to write one microservice. In library, we no need to expose that in any code because we'll use library functions in another module. But if it's microservice, then we have to obviously expose that in a code because all the APIs will expose from that microservice that your consumer will call those APIs. So this is the difference between library and microservice. Okay. Now, what I will show you about this two things. How we are exposing microservice, how we are writing APIs here, and how we are connecting to the databases, all those things. So now we move from our setup part to our actual business logic. We have created different repository for library. You have created different repository for microservices. To refer to this diagram, we have already OMS code, and we have also OMS REST client. Then we have this OMS product microservice. Okay, and we are using in this product OMS core and OMS REST client library. Now we have pushed all these small modules in different libraries, in different repositories in our GitHub. This is OMS product. This is OMS core. This is OMS REST client. Okay. because Go encourage single module per repository. If you want to do like a monolith, then you have to create one repository in GitHub, but in that case, you do not have separate module. You will have only one module. Inside that, there will be different package. OMS core, OMS product, OMS REST client. All those will be then packaged, not a separate module. We have done here module based architecture. We have created separate module, and those modules will be deployed separately. Okay, those microservices will be deployed separately so that we can scale those microservices based on our loads, based on our traffic, based on our users. Okay, if let's say order service require more instant, so we will scale order service, and if some service doesn't require more scaling, then we'll adjust accordingly. That's why we have created separate microservices here. Let me go to the code to explain it. So first I will go to OMS code. This is simple library. So we have some models here because this product module, this order model. So this models will be used generic response model. This is a generic response from any microservice. So this is the structure of our REST API call response. There will be error, boolean, message, string type, result will be map of string interface, and detail will be string. This is our structure. So we all the modules we have defined here, and in our utils we have defined some of the function like configuration load, helper. We have used respond with error, respond with JSON. We have created some common function. Okay, so first let me go to here. So what is our generic response architecture? So what is our generic response structure? So in JSON it will be like it will have error. Okay, it will have error. Then it will have some error, maybe true or false. Then it will have. So why you have written error in E in small, but here in caps? So we are telling that JSON key is corresponding error is E error word in small. For message, JSON key will be message. Okay. Okay. So this is our response structure. Similarly, we have done for product. Product will be stored in database also. So that we have mentioned corresponding basin because we have to store this in our database, Postgre database. So basin is so ID. So this is ID in caps, but in DB it will be the key name will be ID. For name it will be name. Description. Okay, available quantity will be avail underscore qt. Reserved quantity will be reserve underscore qt. So all the things we have already mentioned here. So this is our model. Now we have created some common function. So we have to return some response from our API. Maybe that will be success response or that will be error response. So we have created common function like respond with error and respond with JSON. This is another function, and there will be in respond with error, we are printing some message that your code is echo and your message is echo because we have to give some log statement. about the error. Then we are calling respond with JSON. Respond with JSON, what it will do? It will create. So we are passing W. W is our response writer. Then we are passing code, HTTP code, message, details, and error, and payload is none. In case of error, the payload will be none. What we are doing, if code not equals to 200, we are making is error true. That means there is some error. Now we are creating response. And if error is not, if code is not 200, then error will be false. Then and pay, here we are passing payload as nil, because in case of error there will not be any payload. There will not be any response. Then we are using all those data. We are creating models dot generic response. This one, models dot generic response. Yes. Now we are we have one type. So we are creating now the JSON. We are Marshall. So Marshall, what it will do? Marshall returns the JSON according to the input. So based on this struct, we are converting this to JSON response. Then we are writing that response. And we are setting the content type is application.json, and HTTP header code is code. The code it can be 200. In case of success, in case of failure, it will be 400. It can be any other code. So the common function we have written, we have also written some other common function like GUID generation, convert to map. All those things are there. Now I will go to in our product service. In product service, what we are doing, in product service we are doing many more things. Now I will go to first in the main.code. We'll start from main. So what we are doing here, we are creating one app, core.app. So in OMS product, that means in this module itself, we are going to this core package. Okay. Then we are calling core.app. So it will help us to create our app. Then we are initializing the app, and then we are running the. Let me go to this core folder, app.go. So in our core package, we call core.app. We call this core.app. Okay. Now we have this struct. It has router, it has connection, DB connection. Router means the API router, and we have the config environment variable. We have this app. Now we are calling core.app. We are getting the struct app. Then we are calling initialize on this type. Okay. Now we are creating, we are loading the config. We have an util, utils.load. This util is nothing but defined in our common core module. So it will load our environment variable. If error, then it's printing, then it's connecting to EGX pool. It's a third-party library for connecting to Postgres. Now we are connecting to the database. We are passing config.db URL. We are getting the config. We have already app.env file. Okay, this app.env. Here we have mentioned our server port and DBUR. This is our environment variable. So we will expose all the variables that we are using in our project. So during deployment time, this will be changed to other value based on the environment. Yes, so we have done till this. If we are unable to load database connection, then we are giving the fatal error. Fatal error means we don't want to proceed from here because we have failed to connect to the database. And database is very much essential for us. Okay, now we are printing. If there is no error, then we are printing connected to DB this URL, this line. Now what we are doing? Now we are initializing the connection in this struct. Connection here. Okay, a dot connection, a dot router, then a dot config. This is our config variable, environment variable. So we are loading one time all the environment variable, then we are keeping this here so that you can refer in other files also. Now we are initializing the route. So we have already DB connection ready. Now what we have to do? We have to initialize the routes, our API routes. For that, we are calling initialize route function. Okay, that's one. Now we are creating router, e dot router. We have already created the router here. Go to here Mux. We are using Mux, Gorilla Mux library. For package Mux implements a request router and dispatcher. Okay. So HTTP request multiple. So this library, Gorilla Mux library, we are using for exposing our APIs. In case of Java application, we sometimes use Spring Boot to create the REST API. In Node, we use Express to create the REST APIs. Similarly, here we are using Gorilla Mux. There is no difference. And here we have created the mux.new router. Router, namespace router. Okay, so we created just router. It's in the mux. And we have this kept in the router variable. Now in our initialize routes, we are using that dot path prefix. That means we are defining here all the libraries of this microservice. So this is the base path slash product. So it will be in local HTTP colon double slash localhost colon 3004 slash product slash API slash v1. Then this is our first API. So slash v1 slash find slash ID. ID is the variable, the actual ID of the product that you want to find. And this is a get API. Okay, so here we are defining our handler, our API. So in our handle function, what we have to pass, this is the path of our API and the handler, the function which will handle this get request. Okay. Now this is our definition. Find product. So what it is doing, it's taking the ID where's mux.where's r is the request. Okay, http dot request. From the request we are extracting the ID. That means this ID. Then we are using this ID to find the product. We are calling API.find product. In our API file, we have one function find product. There we are passing the ID and we are getting the response. If I go to this find product, this is in API.go. Okay, this is our connection, this is our config, product ID, and writer, response writer, and request. Here we are connecting to the database. Here we are connecting to the database. Then if error not equals to nil, then we are printing the error. Then we are doing connection dot begin context dot background being begin transaction. Okay, so we are creating the transaction. Then if error, then we are printing. Then if no error, then we are querying px dot query and we are passing find product query and product ID. We have created find product query. Select name, available quantity, reserve quantity from product where ID equals to $1 for update, because it will create a log when we are ready. No one will update this. Okay. So now we are passing this variable. This will be put here where ID equals to the actual ID that we got in the request. So it will create the data error. If error, there is error, then we are printing. If no error, then we got the result. Right? ID, product ID, name will be name, and available quantity will be available quantity, and reserve quantity. We are taking all those results in this variable. We're using those variables to create our product type prod. Now, now what we will do? We will we will create one JSON. We will create one JSON to return the successful response, and we'll show you how we are handling the error a bit later. I think let's move to util. Again, we have one util, common util that is written in OMS code. This will convert this product type to a map. Then we are using this in our respond with JSON function because this accepts one map payload. We will have the payload now because this is the success case. Okay, and we are returning those. In case of, and we are not returning, we are writing the response here from this respond with JSON file. And in case of error, what we are doing, let's say we got error in case in this transaction. Now what we are doing util dot respond with error. Here we are passing the code is 500 internal server error. This is the message, and the body is nothing. Response body payload is blank. It will write the error response. We'll again go to our common function that is written in OMS code. I think now you have a little bit of idea how we are using OMS 4 common functions here and how we are connecting to the databases to find our product. That product which user want. User passed this ID, and we are doing query with that ID in the database. If we get the result, then we are sending the response. And if we got any internal error, maybe during DB connection, all those things, then we are giving internal server error 500 response. Now I will tell you about the environment variable management. We are using Viper, and all the common codes are written in our OMS code. So we have this config.codes. We call this load config, okay, from our VMS product. Yes, this one utils dot load config. What it will do? It will read from the root dot means app.env file, and it will give you all the content to you in this config. Then we can use config dot, let me search it, config, then you can use config dot dburl, config dot dburl, okay? Or you can use config dot server port also. And if you want to know the code what we written, this is our Viper, okay? Viper package. We are using this Viper package to read this file and creating the config. Now you have the understanding. So our product is running on 3004 port. Let me go to the API. So what will be our URL? We have just done that. Our URL will be we have to go to initialize, then we are initializing all the routes. So this will be our base path. Let's give some query tool. Select from, I guess the table name is product. Yes, you are getting all the products. We have three products in the database, P1, P2, and P3. So we hit the API, HTTP localhost 3004 product API V1 fine. This is the ID of the product. And we are getting the result. Error false, message product find successful, result avail quantity, description, ID, name, reserve quantity, and details is. And before that, we are getting some error, then we are getting some success. We'll look into this, why we are getting this error, and we will try to fix that later. So in our architecture, we have start service, we have checkout service, we have order service. Some of the service already written here. Then core we have already explored, OMS REST client, OMS card. We have OMS checkout. We have already seen OMS product. Okay. You have other packages, API, core dispatcher, all those things. So here is an OMS checkout. We have a little bit of more complex logic regarding the worker queue. So there is a concept of worker queue to handle more requests per second. Let's say we have 10 lakh requests per second. Then you should have some queuing mechanism to queue the request, and then from the queue you will take some requests, then you will serve, you will send a response, then you will take other requests from the queue, then you will serve them, and in between the new request that will come, that will be in queue, and you will keep those requests in queue, then you will return the response that saying we have already taken your request, we will give you result after some time, and you will return the response, and you will keep this request in the queue. Later you will use those requests from the queue, and you will process those requests, and you will return the result. Okay. This is the queuing technique. I will explain with diagram maybe later. In this client, I have written a readme file. Here you will mention how your library will be used in other library. Let's say you have written REST client library, and this will be used not only in our other module, maybe some other guys in their projects. You have to produce some good amount of documentation so that they can understand, okay, I have to use this way, this REST client module. So in installation, we have mentioned that if you want to install, you have to use go get, then this is our module name. Then if you want to import, you have to use REST client, then REST util. This will be your import statement, and there is one wrong. Our package name is not, our folder name is not REST util, it's REST hyphen util. REST hyphen util. If we go to here, you have to give this name, REST hyphen util. Okay, so now we have mentioned use this, how we call the function. This is our alias name. So we have to mention our alias name also, like we have mentioned here, REST util. Okay. So this will be our okay. We have to mention this also, REST util. Then you will call this as REST util dot the function get. Then you will get the response. We have mentioned all the things in our GitHub documentation so that any newcomer can read this documentation and use our library. That's the goal.